pay off and how they relate to the circle. So we have one relationship that exists if we have two secants, or if we have two secant and a tangent, and those relationships are the same. It is that the outside length of one secant, so let's say that length, times the length of the whole secant is equal to the outside length of the other one times the length of that whole secant. That's true here for a secant and a tangent. The outside length times the whole thing is equal to the outside length of the tangent times the whole tangent. And this is kind of a special case because the piece of the tangent that's outside of the circle is the same as the whole tangent, so that number gets plugged in twice. So let's see one of those. I have two secants here, and I know the lengths of the outside pieces and the lengths of the pieces inside the circle. I'll start with the formula. The outside of this secant is 5. The whole thing is 5 plus x. We add those pieces together. So it looks like this on the left, 5, the outside, times 5 plus x, the whole. The outside piece over here is 7. The whole thing is 7 plus 2. I wrote that out here. You could have just written 9. So I'll distribute the red, 5 times 5 and 5 times x. Simplify it the right side. And now I can solve for the length of x, which is 7.6. So it's important to know that when you get the whole thing, you have to add the outside piece and the inside piece. You add them. The addition is very important here. Let's do another one. This time I have a secant and a tangent. So the outside of this secant is 8, and the whole thing is 8 plus x. I'm adding the outside and the inside. And then the tangent, the outside and the whole are both the same. They're 6, so I plug that in twice. I start with the formula and plug in. See how the tangent segment, the outside and the whole are the same. I plug it in twice. I distribute the stuff on the left in red, 8 times 8, 8 times x. Simplify, and I get that x is negative 3.5. And I wrote negative length. So pause here and try this one. So I'll start as always with the formula. The outside of one secant is 5. The whole thing is 5 plus x. The outside of the right secant is 4. The whole thing is 4 plus 11, which is 15. I can distribute on the left and then solve for x and get that x is 7. Whenever I have two tangent segments that intersect outside, this is a special case. Those segments are going to be equal to each other, so their lengths will be equal. So the length of OP over here is going to be the same as the length of OQ. So if one because they're congruent. So let's look at this problem. I have a circle and I have a triangle around it. And the triangle is made up of a whole bunch of tangent segments. So right here, this segment and this segment are both tangent to the circle, and they intersect outside of it. So that means they're equal. So since the one on the right is 5, then the x is 5. Over here, this tangent segment is 6. It intersects this tangent segment, so they're the same. So that means that z is 6. And last but not least, this tangent segment and this tangent segment intersect outside the circle. This one is 8, that means y is 8. So this tangent, that is 4, so z is 4. And then w intersects with this guy, which is 7, which makes w 7. So you might like this one better than the first one. So just make sure that you're multiplying the numbers together that come from the same chord. Sorry. So try this one. Find x. So we'll start with simplify. We'll get that x is approximately 2.45. You could say 2.5. It's a long decimal. So go ahead and try these two and make sure that you're giving me your answers online on the Google form. I know we did 3 types, but I'm giving you 2. We'll practice them all in class.